Welcome to Advanced Engineering Analysis. In this introductory video, we will go over the topics that will be covered in this course and the learning objectives. We will also go over the syllabus and the Canvas page of the course and show you how it is structured. So let's get started. So this course cover a variety of engineering analysis methods. So we will be covering about several of them. So let's just start. The first method, engineering analysis method that will be covered in this course will be integration. So I know some of you didn't take calculus before, and like your first calculus course that you are taking, so you might not know what integration is. So integration, it looks something like this. So you have like this summation signs, and you have your function here, and then you are summing like this function over d of x, and that will be like you're you are integrating this function. So integrating this function basically means one meaning of it could be like finding the area under the curve. But depend on how you formulate your problem. Basically, what you are doing, you are calculating an accumulation. That's basically what you are doing. So it could be finding an area under a curve. It could be finding a volume of a sphere, for example, or any shape. It could be finding the length of this curve. That's also an accumulation. It could be finding like the mean value and like the mean value of this curve, and not just the mean value. It could be finding any moments of the curve. Like, so the first moment, that would be your mean, for example. The second moment, that would be like your standard deviation, like the spread of the function. The third moment, that's called like the skewness of a function. So like whether your function is skewed to the left or skewed to the right, for example. The fourth statistical moment, that's kurtosis, and that tells you like the shape of your function, whether it's like a normal distribution, Laplace, or uniform. So that's like in the statistical analysis. So that's also integration, and you will learn this in this course. Like, you will learn also about the moments of the function and how you can use this concept of integration to find like the moments of the function, like the mean, the standard deviation or variance, the skewness, and the kurtosis of the function. If you don't understand what integration is, or you don't understand uh, much what I'm talking about, that's fine. And that's exactly why you are taking this course. In this course, I am assuming that you have zero calculus knowledge, and that's how this course is prepared, by assuming that you have zero calculus knowledge. Yeah. Uh, Another complementary concept, or actually the opposite of integration, that is differentiation. And in differentiation, what we are doing is that we are finding the rate of a change of a function. So that could be finding like the rate of a change, like change in space, a change in time, and you can see that so the differentiation, it would look something like this. And you can see that this is a very important concept in engineering, because in engineering we are, as an engineer, in order to understand a system, in order to so that we can make a design, or we need to see how this system, for example, is changing in space and time. And we generally, and that's where this concept of differentiation become important, uh, because you basically, what you are tracking is tracking the rate of a change, how something is changing, like how your concentration is changing, how you're in space and time, like how your the rate of a change, how your temperature is changing, how the hydraulic head is changing, um, things like that. Yeah. Okay. So that with the so in differentiation, we are trying to find the rate of a change. A complementary, like to extend this, or one application, for example, of differentiation would be like optimization. Like so, find the x that gives the optimum f of x. So in optimization, we generally like trying to find like the maximum or the minimum of a function. So maximum like the maximum efficiency, minimum, for example, like the minimum cost. And how could we find this? So that relates to differentiation, because like these extreme points, like so here, so show you. Let me start writing something. So like this is like an extreme point here. Yeah, this is an extreme point here. This is an extreme point here. This is an extreme point here. What's happening at this extreme point? Like, uh, what is the rate of a change here? The rate of a change here is zero. Like, see, the rate of a change here is increasing. The rate of a change here is decreasing. The rate of a change here is zero. 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 So if we can find the points where the rate of a change is zero, that would be our extreme point, like the maximum and the minimum, and that's like would be the concept of optimization. Yeah. Uh, a similar concept is finding the root of the equation. So like you have an equation, solve f of x, like find x, like so the root of the equation is like find x that make like this f of x equal to 0. That's finding the root of the equation, and that's something you have done before. For example, like if you have an equation which you cannot solve analytically, and then what do? You use your calculator to find a numerical solution, like using any numerical solution, like Newton-Raphson, for example, which is so you will learn like this Newton method in for numerical solution in this course. So to find this numerical solution, basically what you are doing is like you are finding root of the equation, yeah, and you do this numerically, which is something we're gonna also learn in this course. So another related concept to differentiation and integration is ordinary differential equation. And ordinary differential equation, that is when, so that's like wh- where you have like one independent variable. Yeah, so you have like one independent variable and a dependent variable. So like here your independent variable is time, and here for example your dependent variable is y. That could be anything. That could be concentration, like how concentration is changing in time. Okay, so you solve for y as a function of t. So basically, like you have a certain contaminant that is decaying or whatever, or forming in time. So you will trace like how the concentration is changing in time, and you represent this by an ordinary differential equation. Okay, so that's like ordinary differential equation. Another uh, engineering analysis method is like the partial differential equation, and that's similar to the ordinary differential equation, except for partial differential equation you have more than one uh, independent variable. So here your independent variable is t. Here, like for example, you have like two of them, like you have x and y. So, and you here could be anything, could be like temperature, for example. So let's say this is a heat plate or whatever, and then you apply some temperature here, you apply another temperature here, you apply another temperature here, third temperature here, and you want to see the temperature gradient, like what would be the temperature here, what would be the temperature here, what would be the temperature here, and so on and so forth. Yeah. So that is like a partial differential equation, and the partial differential equation you have two, like more, like here you only have one independent variable, here you have like two or three. So that could be like a changing in a space like x, y, z, and time, for example, like four independent variable. Yeah. So these that is a partial differential equation. So you see, like what I've showed you here, all this depend on calculus, and that's why calculus is very important. So one big lesson in this course would be like calculus. Like basically, we will review the concept of integration and differentiation. If again, if you don't understand what this means, that's fine. I assume that you have zero knowledge about calculus, and that's why basically you are taking this course because you didn't take any calculus before. Okay. Uh, what else do we have, or what else are we gonna cover in this course? Uh, Another thing we will cover in this course is like linear algebra. So linear algebra, you have like a system of linear equations that you want to solve simultaneously. And this linear algebra, there are many engineering systems that could be represented by a system of linear equation. Like for example, like for the environmental engineering student, all like water chemistry, that's all like acid-base chemistry, coordination and complexation, redox reaction. What are you doing here? Like in all these systems, you are representing it by a system of a linear equation, like with equilibrium constant, and these are a system of linear equations that you solve simultaneously to find the concentration of different species of your system. Yeah. But other example, like for example, like you have several components that are connected, like several tanks, several lakes that are connected together, and you want to find like the concentration, and they are in each tank. Like you have an input concentration and output concentration, and you want to find the concentration in each tank or in each lake. You represent this by a system of linear equation. So many like structural analysis. Like if you're doing a structural analysis, you can represent this by a system of linear equation. But so like you can represent many engineering system by a system of linear equation, but linear equation are also important for solving numerical solutions. So some of these equation, like as we will learn in this course, like partial differential equation, some of these partial differential equations, they don't have a numerical solution, and you need to solve them. Sorry, they don't have an analytical solution, and you need to solve them numerically. And so how to solve these numerically, we need to use like linear algebra. So that's why linear algebra is important. So linear algebra is important on its own because many engineering system can be represented as a system of linear equation, but linear algebra is extremely important for solving differential equation, numerical solution of differential equation, and other numerical solution, not just differential equation, optimization, anything. Yeah. Uh, one last thing is that is like data-driven methods. So these methods are generally used for, generally speaking, yeah, for the physics-based modeling. But we have other type of model like data-driven model. Data-driven model is like regression, for example, where you don't like represent the physics of your model, but you develop the model based on your data. Like you learn from your data, and based on learning from your data, you develop your model. Versus like a physics-based model, this is a mechanistic model. You represent the physical equation of a system, and then you solve it to see how the system is changing in space and time. Here, you don't have this physical representation of the system. You just learn from the data, like regression. So I have some points here, and then I fit like a model to it. Like that model here would be like straight line. So now if I want to do projection, I just extend this a straight line. Yeah. Okay. So at x is equal to here, for example, y is equal to here. That would be my model. Yeah. So at this x, that would be my y. Okay, so this is called like a data-driven model. Like I build the model just from the data, not based on mechanistic or physics-based like relationship. So example of these are like curve fitting, interpolation, machine learning, deep learning, artificial intelligence. All these are data driven model. Yeah. A simple example like would be regression. So regression that would be like curve fitting or like a machine learning. Yeah. That's a machine regression is a machine learning method. Yeah. Uh, what are we? So this course does not cover like we will maybe briefly go over it over like data driven model just for the sake of completion, but this course is mainly about like more focus on like calculus like integration and differentiation, ordinary and partial differential equation, and optimization and linear algebra. That's like the main focus of this course. Data driven, you can study this in other courses. So you will be studying this in environmental data science, for example. That's an elective course. Yeah. So if in environmental data science, the focus of environmental data science is this data driven methods. Yeah. Uh, Again, if you don't understand much of what I'm talking about, especially like all these calculus terms, don't worry, that's fine. And that's why you are exactly taking this course. Yeah. But I just want to end this slide by just summarizing what I said, regardless of how much you understand from it, is that like these are like what I showing you here. These methods are the building block for compute, like for engineering analysis, for like the engineering analysis, like what you have done in when you were an undergraduate student and what you will be doing when you are a graduate student. That's they revolve around like what you see here, around like these methods that you see here. So these are like the building block for computational and any like computational or any physics based model. Like so, these are like any computational model. This would be like the building block, and that's what you will see and explore in these course, like how uh, these physics-based model or like data-driven models that you are using, like any computational model in general. So in computational models that could be physics-based or data-driven is based on these building blocks. Yeah. Okay. Uh, so in advanced engineering analysis, as I mentioned, like we that involves like using a physical model, physics-based model, or a data-driven model. What does this mean? So that is basically what we will cover in this course. So we will cover physical model, we will cover physics-based model, and we will cover a data-driven model. What is a physics model? A physics model is just what it is. A physical model is just what it is that you just create a physical model of your system. So here you have like a river, and what you do, you just create an actual physical model of your system. Like, for example, like you've done this before in fluid mechanics and hydraulics, is that like using a flume. A flume is a physical model, yeah. So you develop an actual physical model, and you use this physical model for studying like different property of the system, like flow, like sediment transport, like whatever you want to study about the system, like your so the system in that case is called like a prototype. And then what you understand from here, you need to scale it back to your prototype, to your actual system. So you have a physical model and you have your prototype, and you need to scale your understanding from here and the calculations that you made from here. You need to scale it back to the actual system. And to do this, there is a method called like dimensional analysis and pi theorem, and that will help you to scale back from back and forth from like your physical model to your prototype, back and forth. Yeah. And we will learn this in module one of this course. Another types of models that we deal with is physics-based models. So physics-based model, like we describe like the physics of the model using generally like differential equation, ordinary or partial differential equation. Uh, and then we have equations that describes this system. We parameterize this equation and then we solve it. So here I'm showing you an example of a physics-based model that will calculate the hydraulic head. So this is like in the subsurface. This is a groundwater model, a flow model for the subsurface. And what you see here, this is the head, like hydraulic head that the model is estimating. So uh, you see you have high head here, you have a lower head here, so probably there is a lot of pumping here because you have like a lower head here, you slightly you have very high head here, high head here. So in this course, we are not, for example, we're not gonna learn how we're gonna produce like a model like this, like how are we gonna like get this data, and how we gonna use this data to create a conceptual model and then turns this conceptual model to a numerical model uh, and then runs this numerical model and calibrates this model and do an engineering design. That's not like what we're gonna learn in this course, because that you will learn in other course. So like if you want to learn how to develop and set up, calibrate, and like use a model like this for engineering application, you do this in other courses. So you will do this, for example, like this type of model, like the groundwater model. You will do this in a course called like groundwater hydrology. That's another elective course for the graduate students. If you want to do like a similar model about like urban water management, like you do this in an urban water management course. If you want to do like uh, and so on and so forth. Yeah. So what are we gonna learn in this course? Like in this course, what we're gonna learn is the mathematical basics and principle behind these models. So that's the objective of this course. Is like in this course you will learn the mathematical basics and principle behind this course. So that would be the first step. And then after you learn this mathematical basics and principle behind these models, I will you will apply it to simple problem. Like so that is fundamental skills. So like conceptual understanding and fundamental skills. Fundamental skills is that like you learn how to solve like simple problems, yeah, with pencil and paper. So that is the main objective of this course, is this foundational knowledge. So foundational knowledge, that is like the conceptual understanding, like this mathematical basics and the fundamental skills. Let me give you an example. Like that's what you did when you were at school. You first learn conceptual understanding, like what is the difference between addition and subtraction, what's the difference between division and multiplication, and then you did some simple uh, uh, problem solving. That is a fundamental skill. Like you have a fundamental skill of adding 1 plus 1. So 1 plus 1 is equal to what? 2. Or 1 minus 1. 1 minus 1 is equal to what? Like that's equal to 0. Things like that. 1 time 2 times 2, that's equal to 4. Yeah. And so on and so forth. Yeah. Uh, so that's basically like the main learning objective of this course, is this conceptual understanding, like knowing what's the difference between addition and subtraction. In that case, it's not going to be what's the difference between addition and subtraction, but that will be learning about what is integration, what's differentiation, what's ordinary differential equation, what's partial differential equation, what does it mean to calibrate a model, what does it mean to have a boundary condition, what is the first type boundary condition, what's the second type boundary condition. And then you will be able to solve simple problems, simple integration problem, simple differentiation problem, simple what do you call it, like ordinary differential equation, a simple analytical solution for a partial differential equation, and something like this with a pencil and paper. Yeah. So that is the main learning objective of this problem. Then after you do this fundamental conceptual understanding and fundamental skill, I will take you to the next level, which is critical thinking. So in the critical thinking, you will build on the concept and fundamental skill to solve simple engineering problem, not just simple toy problem, but simple engineering problem. So I'll give you an engineering problem like a concentration, for example, or like a change in temperature, or a change in head, or uh, whatever. Yeah, like if you are in construction management, like labor productivity, like describe labor productivity by a system of differential equations, for example, something like this. Yeah, so you will solve like simple engineering problem. So you get to apply the conceptual understanding and the fundamental skill to solve simple engineering problem. But for practical application, like developing a model like this is not will be covered in this class. This will be covered in another class. But in this class, what I will be doing is that I will show you, we will explore practical and real life applications. So for example, like if we will do like partial differential equation, like, so this model basically is like how to calculate the head here. This is basically by solving some partial differential equation numerically. So I will show you this. We're not going to do it, but I will show you like different application. I will show you that's also another important component of this course, is to learn about the real life application of this methods that you are using in engineering, and you see how these methods that you are learning uh, are uh, are the main are the building blocks of all this engineering and of like this engineering analysis that you are doing. Okay, but how to actually set up a model like this, calibrate a model like this, and use this model for engineering application, like where you will actually do it by yourself, that would be in another course. That would be in a groundwater hydrology course. So is this clear? If this is not clear, ask me question, yeah? And I will show you in a minute like how to ask me question. Okay. Like finally, like the last type of models that we use is like a data-driven model. Data-driven model, like basically we learn from the data. Like we have a big set of data, and from this big set of data, you learn something and you develop your understanding. Yeah. Uh, so this would be like we will learn about physical models and dimensional analysis module, like that's module one. Physics based models, that's like module two to four, that's like would be like the calculus part. So in module two we will learn about differential calculus. In module three we'll learn about integral calculus. In module four we will learn about differential equation. And then we will further, like whatever we learned here, we will further explore it in module 5 by about modeling and simulation. And then after we learn about modeling and simulation, we will do module 6 like linear algebra. And I told you like linear algebra is important on its own because many engineering systems could be represented as a system of linear equation, but it's also important for modeling because a lot of the model, like a model like this, for example, there's no analytical solution for it. How did we get this solution? We get it numerically and using linear algebra. Yeah? And then in data-driven models, we will touch on this. That would be in module 7 and module 8. So module 7, that's like Monte Carlo simulation. That's more toward the construction management student. I mean, both of them are good for anyone, like for construction management and water student. But this one, I made it more for construction management student. I show you like how to use Monte Carlo simulation, for example, to learn about like the cost and the budget of your project, for example, and the profit, things like that. Yeah. And then module 8, that's about like linear regression. So I will show you like the basic principle of regression and with application to linear regression. Yeah. Module 7 and 8, these are elective modules, so you don't need to do both of them. You can just choose any one and do whichever one you prefer. I mean, you can, of course, do both of them. Yeah. So that's basically what we will explore in this course, like physical model, physics-based models. You see, like that's the main part, like that's like the calculus part, and then like some data-driven part. So let me say this again. So module one, this is algebra. So I am actually assuming, not just assuming, that some of you don't have like a calculus background, didn't study calculus before, but I'm assuming that some of you are not even good with algebra. Uh, I have one student before who didn't learn algebra. Yeah, he or she didn't know algebra, and then they has to start from learning algebra. Yeah. Uh, so in this module one, we will basically review like algebra and just general numeric literacy like unit conversion, dimensions, things like that. Yeah, what's the difference between uh, units and dimensions and things like that. In module 4, 2 to 5, we will be doing calculus. Module 6, linear algebra, and module 7, that's like data-driven model, like statistical analysis, like Monte Carlo simulation and regression. Yeah. Okay. Uh, so that's basically, so these are the learning objective. I'm not gonna read them. You can pause this video and read them, but this is just like a summary of what I have been what I just said. Yeah. So basically, like just to summarize, you will understand like how these methods that I showed you, like these 8 methods, are the building block of any of the computational models that you are using in engineering. Uh, that's like one thing. And then based on this foundational understanding, you will be doing simple engineering. You'll solve simple engineering problem like critical thinking exercise, and then after you go from this foundational understanding to critical thinking like simple engineering problem, I will show you like a practical application. Yeah, so that's basically, so that's like I call like this the fact framework. So fact, that's like the C stands for conceptual understanding and fundamental skills. So these two are the foundational knowledge. So these are the foundational knowledge. And based on this foundational knowledge, we will explore simple engineering uh, problem to solve. That's like critical thinking part. So that's like fact is like conceptual understanding. F is like fundamental skill. Uh, T is like the critical thinking, and application, like practical application, or this called like authentic learning. We're not gonna you're not gonna like do like a groundwater model on an urban hydrology model or whatever, because that's not what you will learn in that's not like what you will learn in depth or in detail in this course. You will learn these topic in depth and detail, including finding the data and including building conceptual model, setting up the model, calibrating the model, using this model for engineering application in other courses such as groundwater hydrology, urban water modeling, and so on and so forth. In the construction management, that would be you will learn this in your construction management courses. Yeah, and that's why. But I will still show you practical application for both like the water student and construction management students. Yeah. Okay. So this is the course description from the catalog. So I mean, let's just read it. Method of analysis applied to engineering problem. Topic includes a review of vector calculus, linear algebra, analytical and numerical solution of differential equation, finite integral, and computer modeling and simulation. So we talked about this. So now some of you are wondering, like, okay, why am I taking this course? Yeah, like why do I have like, so for example, like one like a construction management student who's working in a construction site, he might say, "Oh, why do I need to like learn this vector calculus, for example, or why do I need to learn differential equation, or and so on and so forth." So that would be one group of a student. Well, like this material would seem like very challenging and seem like unrelated to my career. So why do I have to do this? And the simple answer is like to get a degree in engineering, you need to know calculus. That's basically the simple answer. You cannot have a degree in engineering without knowing calculus, and that's basically why you are taking this course. Yeah. to get a degree in engineering and to know calculus. A second group of student, they might say, okay, like, okay, I took already Calc 1, Calc 2, Calc 3, and this material feels like more basic or repetitive. Like, why do I need to take this again? Uh, and again, like, you are taking this again because if you want to master engineering, you need to understand the concept behind the models that you are using and not just use these models. Like, for example, like a groundwater model, like you need to understand the concept behind this model and not just use this groundwater model, an urban hydrology model, a contaminant transport model, whatever. And that is what you will be learning in this course is like the concept, this foundational knowledge behind these models that you are using. Uh, so, uh, so these are like the two extreme. Like one extreme that this will seem like extremely challenging and unrelated to my career, and the other extreme will see that this course feel like basics and repetitive. But most of the students will not be at these two extremes. They will be like in between. Yeah. So this is actually the oops. So. Uh, so okay, let me uh, so let me answer the second question first, and then I will tell you like the participation activities that you need to do. So the second question is this course challenging? So that is like a second question that the student will have. Like, is this course is it an easy or like a challenging course? The simple answer is this course is easy. It's not challenging. So even if you didn't take any calculus before and this like material seem the very challenging, actually it is not. Like this is an easy course, and I am assuming that you have no prior calculus experience. So I will start from the very beginning, and the course is structured in a way that I take you like step by step, and we will be doing like fun and easy stuff. Like in this course it's really fun and easy because remember we are focusing on foundational knowledge like conceptual understanding and fundamental skills. So most of them that you will be solving in this course, these are problems that are straightforward, that has like a single unique solution, unlike many other courses where like you'll be you like developing, working on like ill-structured projects that has no unique solutions, that requires, that has a lot of ambiguity and uncertainty. This course is not like this. This course you'll be solving simple math problem. It's fun. It's like you can think of this course like in each lesson, what I will be doing in each lesson, I will be showing the concept, and then after showing the concept, we will be solving some practice problem. Like we will be solving before practice problem, we will be solving some examples together, and then after the examples, I will give you some practice problem, and after these practice problem, you will do like a homework problem, and this examples that we will solve together, the practice that will be mirrored in the practice problem, and that will be mirrored in the homework problem. So so it's not challenging. It's an easy and fun course actually. For other students, they said, okay, like that might be like repetitive for me, and I already took this. Actually, no, because let's say, for example, like calculus, yeah, like so in the first week, it would be like things that you already know, things that you have learned before. So that would be like a review for your calculus. But in the second week, it would be new material. It would be a new material beyond what you learned it in Calc 1 and Calc 2 and Calc 3. That would be one difference. But the second difference, when you took Calc 1 and Calc 2 and Calc 3, you took this properly with a math teacher, somebody from the math department. This course, you are taking it from I'm an engineer, like your course instructor. I'm an engineer. So I'm giving you this from an engineering perspective, focusing on engineering and application and not just showing the math part of it, but showing why and how this is important in engineering. So that is what will be different than what you did in your calculus course, is that like in this course that will be happening from an engineering perspective. So is this course, like to answer the second question, is this course difficult? No, it's not difficult. Like not difficult like other courses. So like in this program, for example, other courses that you will take, like research methods and project. These are challenging courses because these courses require, as I said, like higher order thinking and very deep and critical thinking and things that are does not have a unique solution, projects that are ill structured and requires a lot of effort and lot of understanding. But this course just simple problems that has a unique solution. It's just fun. Yeah, it's basic concept and foundational skill. So in that case, it is fun. But now I want you. This is your participation activity. So in the I will show you this like in Canvas, but in the discussion form in Canvas, I want you to answer this question: like, where do uh, you stand on this spectrum on finding like this material too basic or too challenging? So just let me know, like in this spectrum, like some student will say, oh, this is too challenging, I never took any calculus before, that sound difficult to me. Other will say, oh, this is too basic. That's the too extreme, yeah, and repetitive. And most of you would be in between. So I just want you on this spectrum, I want you to tell me where do you stand, and what steps are you can take to get the most out of this course. So like if this course, like this material are totally new to you, what steps are you planning to take to get like the most out of this course? Or if this material it seems like repetitive to you and you already know all this, what steps are you planning to get most out of the course? uh, so for example, like I told you, I had one student who he or she didn't know algebra, basic algebra. So what that student did is that he, like or she, watches some YouTube video about linear algebra, for example. Yeah, yeah, things like that. Yeah. Other student will maybe didn't take any calculus course before. What extra step you can take is that uh, you can get like a calculus book and start like learning more and solving more practice problem, or you can use generative AI to generate more problem and more practice problem for you to solve. Yeah, that's I'm just telling you some example of steps that you can take. If you already studied this material before or studied calculus before, what steps you can do to get like the most out of this course? So some of uh, the steps that you can do, that could be, for example, the steps you can do, that could be, for example, to dive deep into the practical applications that I will be showing. So I will be showing you some practical application, including like research papers. So you dive deep in this and read them and find more like example and things like that. Yeah. Okay, so how's this course in structure? So the first step is like you need to watch these videos. So that you will watch these video, that would be part like your participation grade. So you watch the video. Uh, in this video, I will be solving some exercise, and then I will be showing you practice problem to solve in your own. These practice problem, I solve them in tutorial video. So these tutorial video are optional. You don't need to watch the tutorial video. If you can solve the practice problem in your own, you don't need to watch the tutorial video. If you cannot, then you need to watch the tutorial video. Yeah. Uh, and but the lecture video, the main video, this is required. And after each video, you need to provide like an exit ticket on the discussion board. And this exit ticket, you just give feedback about like this video. That is like, so this exit ticket each video, each of the lecture video, each of the required video require an exit ticket. These exit tickets, that is your communication with the course instructor. So that's where you will give the course instructor like a feedback about your learning, about what you find useful in this video, what you find it challenging. If you have any question to the instructor, so that is will be your discussion with the instructor, those exit ticket, yeah, uh, those exit ticket, and you can give any feedback, yeah, okay, to the instructor, and then for each module, you need to ask one question and you need to answer one question. That's your discussion with your classmates. So you have two discussion. You have discussion with the instructor. That's like in the exit ticket, and you need to clearly mark like this is my exit ticket, and then you ask your uh, that's your discussion with the instructor, and then you have like you need to for each module you need to ask one question and answer one question. So you'll ask one question to the class, and based on the questions that are being asked you can answer any of the questions that your classmate asked. So you need to have discussion with your classmate, and you need have to that's through asking asking one question, answering one question for each module, and then you need to have a discussion with your instructor, and that's through the exit ticket, yeah. And why am I asking you to do this? Because we learn better when we interact, when we learn together. That's how we learn, right? If you are learning on your own, that will not be as a rewarding learning experience versus if you are learning with others. You must watch this video. So some of you might say, okay, I know this material. I can just look at the slide. I don't need to watch the video. I can look at the slide and then solve the homework problem. It doesn't work this way, because in this video, that's where I tell you my experience, which is not in the slide. And in this video, more importantly, I tell you my expectation. So these videos are absolutely must. You must watch them. And uh, from like the previous semester, like all the students they watched all the video, yeah. So I didn't really have any problem with that. Like all the students they watched all the video, because that's how you can solve the homework problem, yeah. And most importantly, that's how you will be able to do like your your final exam. So basically, after in this video, as I told you, we will solve some exercises together. There will be practice problem which you'll solve in your own, and you will find I will provide you with the solution, and I will also provide you with video tutorial video to show you how to solve them. But if you were able to solve this exercise and practice problem, you will be able to complete your homework easily, yeah, and get the full mark here. And that will, so your homework will mirror the exercise and the practice problem. And then how to ace the final exam? Well, watch the video, solve the exercise, the practice problem, do your homework, and your homework, it will mirror like basically the exercise, the practice problem, and the homework problem. So your final exam, it would be open book, but no open internet. So it's an FE format. So you are not allowed to use like the internet. You are not allowed to use so to use the internet, and it's like a traditional pencil and paper exam. And basically, what you are doing this semester, what you are doing, you are spending this semester preparing for this final exams. That's what you are doing in this semester. You are spending the semester just preparing for the final exam. How do you prepare for the final exam? You solve the exercise problem, you solve the practice problem, you solve the homework problem, then you are ready for your final exam. So these are the tasks. Each video, you fill an exit ticket. Each week, you have a weekly homework about like the videos that you watch. Uh, Feedback and learning assessment survey each module. So each module you will there will be like a learning survey that you have to fill, and each module you need to ask one question and answer one question. So the part of this feedback is that you will have to record. You will say, okay, I asked this question and I answered this question. So you will have to record this in this assessment survey for each module. And then there will be final exam at the end of the semester. Yeah. So I think that's all for this. Let's just go to the Canvas course and just show you what is what. So here, like your Canvas course, it will look something like this. So this is this introductory video. I just put it here. So you watch this. This is the video that you're watching now. So to get started, you need to watch this video. And here's some important navigation, like so the recorded lesson. So that's like you go to the YouTube channel, and in this YouTube channel, you will find like the recorded lessons. Here you will find the discussion. This is the administrative thing. You will find the syllabus and things like that. The most important one is the modules and the file. So the modules here, if you click on the modules here, which you can also click it here, then you will find like those modules. So this module 0 is an introduction, and so you will see the videos that you need to watch, and then you will see the exit ticket, and I'm giving you instruction here on how to do the exit ticket. So here, like, you have two tasks. You have to do the exit ticket. So after each video, reflect and submit your exit ticket by responding to the or sharing general insight, like so the exit ticket, like I think I should make this a little bit. So uh, like so the exit tickets, that's your communication to the instructor, yeah. And the participation activities, the participation activity here would be, what is the participation activity here? That would be like this question, answering this question, yeah. So you will answer this question, and in addition to answering this question, so that's the participation activity, you have to write like you have to answer the exit ticket by just describing a concept or skill you found engaging or useful, for example. Interest in topics that you want to explore further. How do you plan to apply the knowledge that you learned in this lesson, for example? Challenges that you face and suggestion for improvement, feedback on teaching and method material, or like if you don't have any comment, a simple thank you, yeah. But you need to provide a meaningful feedback. Like thank you, that's a meaningful feedback, yeah? But saying something like no comments, that's not a meaningful feedback, yeah. So you just like after each watching each video, you need to provide like these exit tickets, yeah. And then here let's just go to like those modules. So in those modules, so that's like, let's say module one, dimensional analysis. So if you go to module one, here is the lecture notes. So like if you download this, that would be like the lecture notes for this module, and that would be like the lessons for those modules. So in week one, uh, you have so you have like this lesson, it's a 40-minute lesson. You have this lesson, it's a 17 minutes lesson, and this is a tutorial. So the tutorial, you don't need an exit ticket for this. So here, like, you need an exit ticket for like this lesson, like for this video. You need an exit ticket for this video, and this one, this optional. So you don't need to watch it. Like if you want to watch it to see how the practice problem is solved, you can watch it. If you can solve the practice problem on your own, you don't really need to watch it, and it does not require an exit ticket. So you'll watch the video and you'll provide your exit text here. And then what else are you going to do? And then after, let's go to modules. Uh, so after you do this one, then there will be a homework. Yeah. So like this homework, you will just take it online, and so you'll have a problem, and then you will answer it. So that's like your homework. And see, the homework is very simple, like 2 questions. That's it. Yeah. And so that's like your homework for week one. Yeah. And how to solve this homework? You do the exercise, you do the practice problems, then you're ready for your homework. Yeah. And in order to solve this homework and get this grade, you need to be able, you need to watch these videos. Yeah. Uh, and you need to watch this video to do good in the final exam. Yeah. Okay. What do I have here? So that's like the modules. And then at the end of the module, you have to complete this survey. This survey you will reflect on your learning, and I will just see uh, like that's basically where you will reflect on your learning, including you will record your like see this like log your participation by recording the date of the question you ask, the date of the question you answer, and was that useful learning experience. So remember, for each module, that's like you have two discussion. I'm repeating again, like you have one discussion with your instructors, that's the exit ticket, and then you have one discussion with your peer. That is for each module you have to ask one question and answer one question. And then here you don't need to record the question, you just record the date I asked this question, or you can whatever do it like, but I need the date, like I asked this question in that date and I answered this question in that date, and I found this useful learning experience or not. Okay, so I think that's that's all. Like here, like if you go to the files, you will find also for example, like you will find the files, like this is the raw files that I'm sharing on this module, like the lessons you will see for each lesson. Sometimes you will see additional files here, like integral calculus. I mean, this is the PowerPoint and Excel. So yeah, if you want to just go to the files, you can. So for each, like let's say regression analysis, like these are some files, like these, this is a Python notebook, this is an Excel file, and so on and so forth. Yeah. But so that's all for the Canvas course. This is my office hours. So office hour at Tuesday and Thursday from 2 to 4, and by appointment. How you can schedule an office hour with me? Like very simple. Like you click on this link, and on this link that will show you like my availability. So let's say you want to book a meeting with me on Friday, so you will see here my availability on Friday. Yeah, and then you can just like select, like if you want to book a half an hour, you select, do one. If you want to book 1 hour, then you do one, and then you do another one. Yeah, you have to do it twice. Yeah, so let's say you want to meet with me on Friday at 6 a.m. Then you do here, you just write a note. So in the note, like I'm telling you, like the purpose of the meeting, like you want to discuss like your homework, advising, or whatever, and then whether you want to meet in the office or meet on Teams. For this early morning meeting, I don't do this early morning meeting in the office. Like if you want to do 6 a.m. or 6:30 a.m., this will not be in the office. This has to be online. Yeah. Because simply the building will be closed, and you don't want we don't want to be the only two-person in the building. Yeah, that's not good. But starting from 7 a.m., yes, we can meet in person. Okay, but this one we don't do them in person. This has to be online, so that's also need to be clear. Okay. And then the final exam that will be in person, will be conducted in person. When is the final exam? Like, do I have information about it here? Course schedule. Yeah, so the final exam that would be in April 29, Wednesday, April 29, from 6 to 8 a.m. The location where it will be, I will let you know the location. It will be probably, most probably somewhere in Holmes Hall, but I will let you know the location once I reserve the room for it. But that will be an in-person final exam from 6 to 8. Yeah. So I think that's all for this part. The Canvas course. Like again, if you have any question about the Canvas course, let me know. I don't want to keep this long. This is the syllabus. So this is an online syllabus, but now I'm also using this one, like the simple syllabus. Uh, uh, so this is a simple syllabus, uh, which you will find here. So I mean, again, there's nothing really special here. This is my office hour, how to meet with me. So you have a link here If you want to just, which I just showed you, these are the learning objective of the course. These are the course materials. So these are the books that I used to prepare this material. Do you need to get these books? No, you don't. But if you want to learn more, you can get them. So this is optional. This is up to you. Like, so this is, that's why optional, optional, optional. So for example, like module 2 and 3, I prepared like module 2 and 3 from I use this book, yeah. Module like 4 and 5, I prepare them using this book, so on and so forth. So another thing that you will learn also in this course, so since we are talking about this book, is that FE exam. Remember, we are learning fundamental foundational knowledge, fundamental conceptual understanding and fundamental skill. This is what the FE is testing, like these fundamental skills. So a lot of what you will be doing in this course is that you will be practicing for your uh, FE and PE exam. Yeah. So that's what you will be doing also in this course. Like a lot of the problems that you will be solving, I got them from FE and PE exam books. Yeah. Or similar to them, not exactly the same, but similar to them. So these are information about the final exam. Again, the most important information is that no internet is allowed, and this would be an in-person exam. And to do good in this exam, you watch the videos, you solve the exercise, you solve the practice problem, you solve the homework problem. This is the grading scale. You can look at it. We talked about the assessment plan. Uh, This is just like the topics, the schedule of the topics that we will be covering in the course. As I mentioned, like all these modules, this is an elective module, like the last two modules, these are elective module. So in week 15, you can either do the Monte Carlo simulation, like for cost estimation, or you do like regression analysis, like linear regression. You only have to do one. And homework 14, that's something generic, like basically in homework 14, what I'm asking you to do, any concept you learned in this course, just apply it. Yeah. Select any problem of your interest and apply this concept to it. So you can basically can do homework 14 anytime during the semester. You don't need to wait until like this week to do it. Yeah. And then the final exam, you can read more information here about like the final exam. So if you clicked here, uh, you can find like more information about the final exam. Okay, this is late submission. So late submission, that will be strictly applied. There will be a penalty of 20 percent deduction per day, because I want you to stay on the top of this material. Yeah, and that's why that will be strictly applied. So make sure to submit everything on time. This like excuse like this policy will not apply for excuse absent, but excuse absent, like if you tell me, oh, I am not feeling good today, this is not an excused absent. If you tell me, oh, I have to travel today, this is not an excused absent. Or because you need to manage, you need to, like, you're a graduate student, you are mature now, you need to have a good time management. That's also one thing we are assessing. Like, is this student has a good time management? And that's also why I am applying this the deduction to see your time management skills. So that's something you have to manage on your own. But excuse absence, that's required like written documentation from a certified medical profession. So telling me, oh, I'm not feeling good today, that's not excused absent. And remember, like, you have a whole week to do this homework. So don't wait until like the last day where you will have a flu or have a cold and tell me I'm not feeling good. Because my answer would be like, okay, you have a whole week. You just developed the flu today or yesterday. Yeah, something like this. And then also, so the excuse absent requires like a written documentation. Yeah, or for faculty member or administration coach or athletic director, absence will be excused after the verification of the submitted document, because uh, It's not common, but some students they can also forge these documents. Yeah, so it will be validated. Yeah, I mean it didn't happen to me this, but I've heard from other faculty they said this and that had like some sequence. Like I didn't experience it myself, but I've heard this from other faculties that some student will forge, for example, like a medical certificate or things like that. Yeah. And attempt to falsify document will be taken seriously. Generative AI use, like you are not allowed, like you are allowed to use generative AI for learning, but you are not allowed to use generative AI in solving your homework. And you are, of course, like the final exam is closed internet, so you are not allowed also to use generative AI in your final exam. And that using generative AI will result in zero and not only it will result like you can use it for learning, you can use it for learning anything. You can not only you can use it, I encourage you to use it for learning, for solving additional practice problem, for solving additional learning more. These are very useful tools, but bear in mind of course that they also make mistakes, so you have to make sure that like you verify that you are not getting the wrong answer. So they make mistakes, but they're excellent learning tools. So you are highly encouraged to use them for learning, but you are not allowed to use them for solving the homework problem and the final exam. You are not also allowed to use them, and that will be considered academic dishonesty. So you're not gonna only uh, get a zero. So academic dishonesty, an assignment, project, or exam will result in a grade of zero for the submission and will be strictly addressed within the FGCU policy and procedure. And you can check this policy and procedure here. So these are like if you want to learn more about the topics that we cover in this course, you can learn about this here in so I mean you can just like read these are the topics that we're gonna learn and this is the course map like so if you want to learn these are the course learning objective and how these course learning objective like the objectives the learning objective of each module and how these are mapped in assessment and instructional material and so on and so forth. Yeah, so I mean you don't need to if you want to do this like this is additional information if you for curious student. Okay, so now for this week, what do you need to do? Like, so for this week, let's just go here. Uh, this week you have a lot to do, like in week one. Yeah, so in week one, all these homework are due on Sunday. So by this Sunday, what you have to do, you need to watch this video. Yeah, and provide your exit ticket and then you need to get to know you survey so you need to fill out this get to know you survey and upload so this basically in this survey I just want to learn about you and your background so that I can adjust the scores accordingly and your expectation and then for this week what you need to do is that like you need to watch like these two videos and do the exit ticket for each of them and then do the homework. Yeah, and all these are due by Sunday. And for each week I try to give you remember like each week you have to attend two classes and each class is 75 minutes. So each week I try to keep the videos, the amount of videos that you watch less than 2.5 hours. Yeah. So that's my promise to you that so for example, like this video that you are watching now is like about like it's less than 75 minutes and you have another two video which is 1 hour. So everything is like less than 2.5 hours. Okay. So I think that's all for this. If you have like any questions, just like let me know. Like if you have any questions, just like let me know. And uh, and yeah, good luck in this semester. What I didn't tell you, let me go back here. I think I forgot to tell you this. Uh, uh, like how to get an A in this course. So I will end this video. I think that's a good way to end this video is how to get an A in this course. Very easy. This is an easy course. But this is an easy course if this is an easy course if you carefully watch these videos, you solve the exercise in this video with the instructor, you do the practice problems, you do your homework problem. If you did this, you will ace your final exam and you will easily get an A. And that is my expectation from my student. That's what I expect from all my students. I expect all my students to get an A. So I have a very high expectation from you. I expect all of you to get an A. How to get an A? Watch the video, watch the video, watch the video. Solve the exercise and the practice problem and complete the homework accordingly. Okay? So that's all. And in the exit ticket, let me know if you have any questions. Okay, thank you, and good luck. And I'm looking forward for a very fruitful and very productive and very interesting learning experience.